Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Visible Arrows 8 by MD88 Keys, or as I like to call them, Dr. Piano. That's not how I don't think they necessarily go by that title, but it always just, strokes my fancy there. So apologies if you don't enjoy that moniker, but and let me know if you don't, and I will stop calling you that then. But that's what it always reminds me of. Anyways, let's get to the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9, such that there are no repeats in any row, column, or designated 9-cell region. We have counting circles, where a digit in a circle indicates the number of circles which contain that digit. So, for example, say we had a 3 here. That would mean there are 3 3s in total in the circles. We also have arrows, where digits in a circle also equals the sum of the digits on each attached arrow. So say, for example, we had a 2 here and a 2 here. This would then have to be 4, because these two digits must add up to what's in the circle. And they say digits may repeat on a circle. So this is an example of a digit repeating on an arrow. Did I say circle? I meant arrow. Apologies. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. This digit is the sum of 3 unique digits. This digit is the sum of 3 unique digits and another digit. Let's count how many circles there are. Maybe let's start with that. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There are 17 circles. So it could be something like 8 and 9. It could be something like, we know we have a digit from, so this is 1, 2, and 3 at minimum. And this is 1 at minimum. So we definitely have a digit 7 and above. We could have 2 digits 7 and above, though, also. Okay, we do have 2 digits that are 6 and above, at least. So this digit is at least 7, 8, or 9. Because this must be 1, 2, or 3 at least. We're guaranteed a 1 here, right? This is at most adding up to 8 because we have another digit here. So this has to be 1, 2, or 3 here. This cannot be 6. Because, again, this is 1, 2, 3 at minimum. That's 6. Plus 3 at most adds up to 9. This can never be 1, 2, and 3 either. So this has to be 7, 8, or 9. Okay. So because of that, we know this, again, this can't be 6 because it can't be 1, 2, and 3 added up because that would eliminate all possibilities for this cell. So these 2 digits are different digits, and those digits appear again as many times as the digit they are, right, in circles. And we have 17 circles, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So, if we add, and the thing is, I think every circle We could have 2. There are possibilities for a 2. But this can't be 1. But this could be 2. So this could be 1, 1, 2. This could be 1, 1, 2. So a digit in a circle can never be 1. Interesting. So where are the possibilities for... Okay, so this has to be 7, 8, or 9 because it's the sum of 3 digits. 3 unique digits, same as this. This is 7, 8, 9. In fact, this probably has to be the same digit as that. Maybe not necessarily. Hard to say. Sum of 3 digits. We don't have anything there. So this is 7, 8, 9, 7, 8, 9. It's either 8, 9, or it's 2, 7, 8 for the digits in the circle. Huh. Interesting. And the reason why we know that is, again, because we have 17 circles. These are 2 distinct digits, which must be 7 or greater. Because this is a sum of at least 1, 2, 3, and 1, which is 7. Oh. It cannot... Well, if this is 7 here, this is 1, 2, 3, and that's 1. And that would force this to be 2, 3, 4. So that would have to be a 9. And if this is 7, this would be then 1, 2, 4 adding up, which would force this to be 3. And 3 plus 1, 2, 3 at minimum is 9. So you're guaranteed to have a 9, so that it can't, and there's none of these circles can be 1, because they're all the sum of 2 unique digits. So therefore, the digits in the circles have to be 8 and 9. So this is 8 and 9. This is 8 and 9. This is 8 and 9. We know this is a 9 because we have 8 digits in circles everywhere else, and this is the only digit that's in that box. So this has to be a 9 here, which forces this to be 8, this to be 9. That forces this not to be 9, so this is 8. This is 9. That's 8. This can't be 8, that's 9. This can't be 9, that's 8, which forces this to be 9, which forces this to be 8, which forces this to be 9, and this to be 9. That forces this to be 8. And we don't know about these. Right? Okay, so that tells us a lot of information. This is 8, 9 as a pair. 8, 9 as a pair. Eight's one of those two. Eight's one of those two. 8 has to be one of these two. Oh, that's interesting. So if this were 8, that would force this to be 9, which would force that to be 8, and then 8 plus another digit is never adding up to 8 in normal Sudoku. So this can't be 8. This must be 8 here. That's 8 and 1, adding up to 9. So this can't be 8. This is 9. This can't be 9. That's 8. So this cannot be 3 here. This cannot be 5 here. And we're guaranteed this is 1, 2, 3 or 1, 2, 4. 8 eliminates 8 here, so that's 9, which makes that 8. This Remaining digits in row 7 are 3 through 7. No 4 here. So this is 1, 2, 3, and 5 to add up to 8 here. So these add up to 17. Which means these two must add up to 11. 17 times 2 is 34. 45 minus 34 is 11. So this adds up to 11 without a 9, without an 8. So it's either 4, 7, or 5, 6 here. Interesting. To add up to 9, this is 2, 3, 4, 5. To add up to 8 here, this could be at most 6 here. This has to have a 1. And then you could have 6 and 1 here. Or 5 and 2 here. 4 and 3 here. 3 and 4 here. 2 and 5 here. So those are those possibilities. If it's 1, okay, to add up to 8 here, cannot have 4. You can't have 7. So it's either 2, 6, or it's 3, 5 here. Okay. So one thing we do know, okay, so anytime you have 3 unique digits adding up to another digit, you're guaranteed 2 out of those digits must be from 1, 2, and 3. So this must be either 3, 1, and 5, or this is 3, 2, 4 here. And because this is 1 or 2, this is guaranteed to have a 3, and the other 1 or 2 is there, so this can't be 1, 2, or 3, and along with 8 and 9, that forces this to be 4, 5, 6, 7. Okay. Well, if this is 3, 5, that would force this to be 2, 4. These are 1 through 6 here. Which means, where is the 7 in column 1? It cannot be any of these cells here, so it must be one of these 3, which eliminates 7 in the rest of the box. So to add up to 9 here, this is 3, 4, 5, 6, with this 3, 4, 5, 6. This is either 1, 7, 2, 6, or 3, 5 to add up to 8 here. Same here. 1, 7, 2, 6, 3, 5. 1, 7, 2, 6, and 3, 5. Where is the 1 in box 6? It has to be one of these 2 digits here, which means this cannot be 1 here. I don't know how I deleted that. No 1. This adds up to at least 3. So this has to be 6 at most. Which means 7 is one of these 2 digits. This can be 1 plus 1 and 7. So any of 1 or 7 is available there. these can be... So these two digits can add up to 7. Or it's 3. So this digit, you either have 1, 2, and that's 5. Or this is 1, 2, and this is 5. And this could be up to 6, right? You could have 6, 1, and 1 here. So 7 in box 4 has to be one of these 3 digits. If this is 3, 5, this has to be 2, 4. And then you would have 6 and 7 remaining in the column. If you have 2, 6 here, this would have to be 3, 4 or 3, 5. We don't know which. But it would guarantee there's a 3. So then this would be 4, 5 with 7. And we don't know which. Okay. Let us see. We know there's a 1 guaranteed here. Okay, so there's a 1 guaranteed here, which means this cannot be 1. Because this can't be 1 to add up to 9, and this is 11. 1 has to be one of these 2 digits here. So that means that's why this couldn't be 1 there. So since this can't be 1, this is 2 at least, which means this adds up to 6 at most. So this cannot be 6 here. Okay. Again, anytime you have 3 unique digits adding up to another digit, you have to have at least 2 digits from 1, 2, and 3 in that set. Because again, if you could have 6, which is 1, 2, and 3, so that's all 3 of the 1, 2, and 3s available. 7 is 1, 2, and 4, which has 1 and 2. 8 can be 1, 2, 5 or 1, 3, 4, both of which contain 2 digits from 1 through 3. And 9 can be 1, 2, 6, 1, 3, 5, or 2, 3, 4, all of which contain 2 digits from 1 through 3. Since this is 1, 2, or 3, this is 1, 2, or 3, this cannot be 2 or 3 here. So one of these contains a 1, 2, or 3 here. There's 2, 1, 2, or 3s accounted for here, so this cannot be 2 and 3. So this has to be 4 and 5 with 4 and 5 to add up to 9. So that eliminates 4 and 5 in the rest of the box. So this can't be 5, no 4, 5, so this is 3, 6, which adds up with 3, 6 to add up to 9. No 4, 5 here, no 4, 5 here. We have a 3, 6, 7 triplet in box 7, which eliminates 3, 6, and 7 in the rest of the box. So this cannot be 3 or 6. It's 1, 2 as a pair. 1, 2 adds up to 3 with 5 makes 8. So this is 5. This can't be 5, and it cannot be 3 or 6 because these are different 3s or 6s there to add up to 9. So this is 4 or 7. Well, where is a 5 available in row 4? It can only be here. So this is 5 and 3. That eliminates 3 and 5 here. So this must be a 2, 4 pair, which means this cannot be 4, 5. This is not 4, 5. This is 6, 7 as a pair. This 2, 4 plus 3 adds up to 9. So this can't be 2. This is 1. So this must be 1, 2, and 4, adding up to 7 with the 1 here, making it 8 total. So this can't be 4. This is 7, which means this can't be 7 here. That's a 3, 6 pair in box 7, which eliminates 3 and 6 in the rest of the box. So this can't be 6. This is 7. To add up to the 8, it has to be 2 and 5 here. 1 and 2 cannot be here. So this can't be 2. Therefore, this is 3 at least, which means this adds up to 5 here at most. 3 eliminates 3 here, so no 5 here. No 4, 4, or 4 here. This 7 eliminates 7 here, so this is 6, which makes this 7. So that leaves this as 7. This cannot be 3, 5, or 6. This can't be 6 or 7 or 5. There's no 5 here. No 7 here. If this were 6, this would have to be a 1, 2 pair, which would eliminate all possibilities for that cell there. So this can't be 6. We are guaranteed a 1 in this cell here, because this can't be 1 and 7. This can't be 1 here, so 1 has to be along this arrow. So it's either 1, 2, 6 or 1, 3, 5. And this is 2, 6, or 3, 5. So we have a 1, 2, 3, 5, 6 quintuplet, which means this can't be 5. This is 4, which forces this to be 5. So this cannot be 3 and 5 here. This cannot be 1, 3, 5 here. So we're guaranteed this is either 1, 2, 6 or 2, 3, 4. Well, if this is 1, 2, 6, that would eliminate all possibilities for this cell. So this has to be 2, 3, 4, and this can't be 2 and 6. It's 1 and 7 as a pair. So this can't be 7 there. 1 eliminates 1 here, so this is 7, and this is 1. There's no 1 here. The remaining digit in column 2 is a 6. 7 eliminates 7 here, and this can't be 1, so this can't be 1, 7 as a pair. No 1 and 3 here. Okay, this can't be 7 anymore because of 7 in the row. We have a 2, 3, 5, 6 quadruplet in row 6, which eliminates 2, 3, 5, 6 in the rest of the row. So this must be a 4, which eliminates 4 in the rest of the box. 3 in row 6 has to be one of these two digits. That eliminates 3 in the rest of the box. So if you have 3 here, this has to be 1 and 4 to add up to 8. If this is 5 here, it's 1 and 2. So this is guaranteed to be a 1 here. So this is 1. Where is the 7 in column 3? Can't be here because of 7's in the boxes. Can't be here because of 7 in the row. So this must be 7 here. And that's 7 and 2 adding up to 9. That eliminates 1, 7, and 2, 6 as possibilities to add up to 8. So this is a 3, 5 pair, which eliminates 3 and 5 in the rest of the row. This can't be 1 and 8 to add up to 9 because of the 8's already in the box. So this is 2. This cannot be 2 here. This could be 2 here, though, and that's 7. This can't be 3. And this can't be 3, so no 3, 6. No 4, 5, because these 3 5s both see both of these cells. These are in the same box. These are in the same row. So that's no 3, 6, no 4, 5. So this has to be 2 and 7. So that's 2 and 7, which eliminates 2 here. This becomes a 1, 4 pair in box 9, which eliminates 1 and 4 in the rest of the box. So this can't be 4. This is 2. That's no 2 here. 2 eliminates 2 here, so that's 4. This can't be 4 here. No 2 here. So we have a 1, 6 pair remaining in row 2. And this can't be 1 because of 1 in the column. So this 6, which makes this 1. No 1 here. 2 here eliminates 2 here, so that's 4. So 1, 4, and 3 add up to 8. 6 eliminates 6 here, so this is 3, which makes that 6, which makes this not 6, so it's 3 and 5. So there's no 3 and 5 here, no 3 and 5 here. 3 eliminates 3 here, so that's 2 and 3. 2 eliminates 2 here, so that's 6 and 2. 2 eliminates 2 here, so it's 4 and 2 there. Therefore, this can't be 2 and 6 here. 3 eliminates 3 here, so this is 2 and 6 adding up to 8. 5 eliminates 5 here, so that's 6. This can't be 6 here or 6 here. This can't be 7 here because of 7 in the column, so this is 5. That's 7. Remaining digit in row 4 is a 7. Remaining digit in row 5 is a 5. 5 eliminates 5 in the rest of the column, so this can't be 5. That's 3 and 5. Remaining digits in box 2 are 1 and 4. This can't be 1 here because of 1 in the row, so this is 4, which makes this 1. 1 eliminates 1 here, so this is 4 and 1. 4 and 1 eliminate 1 and 4 here. 3 eliminates 3 here, so this is 2 and 3. 2 eliminates 2 here, so it's 1 and 2. This must be 2, 3, and 4 adding up to 9. This digit left is a 5. Remaining digits in row 1 are 4 and 3. And this can't be 3 because of 3 in the column, so that's 4 and 3. We have 5 and 6 remaining. This can't be 5 because of the 5 in the column, so that's 6 and 5. That leaves this as a 6 and this as a 1. And that's a solution. Yeah, pretty interesting. It definitely used the 2 of the unique digits. If you have 3 unique digits adding up to a single digit, you have to have at least 2 digits from 1, 2, and 3 there. And then that combined with this essentially opened everything up. So that was good. And then obviously you had the previous break-in of 8s and 9s, right? And then you just basically go through the scenarios where what happens if we try to make this 7 and 8, and it just doesn't work, right? So you know it has to be 8 and 9 because no digit in a circle can be 1. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.